Hello, this is Mike, and in the first part of this project I showed how I used a microcontroller and a photodiode to measure the light going through a camera and be able to measure the shutter speed. In this second part I'm going to show how I made this concept into a handheld device. First, I added a small display. This is a 128 by 32 OLED display, 0.91 inch. It has 2 pins for the power and 2 pins for the I2C communication protocol, which are connecting to GPIO 0 and 1, which support I2C. I asked ChatGPT to generate a small library to control that display, and this is what it gave me. It took a couple of iterations, but it's working, and it's about 100 lines, and the only thing I need is to draw text. Here is a small test that I have written. I only need to display 4 messages, one which will be reset, one which will be ready, the value of the measurement, and finally a low battery alert. ChatGPT generated the font for me, but only for the characters I need. We've seen this code in a part 1, but I reworked it a little bit to add display. So when it is initialized, I am asking to press reset. Then it says it's ready to measure, and then we display the measured value of the exposure, of the shutter speed. And finally, in the case of low battery, I disable the whole thing, so it's no longer working if the battery is too low, and I display this message. The PiPico has a very convenient internal mechanism to measure the battery voltage level through the channel 3 of ADC, which is GPIO 29. And here I put 2 seconds, but it's 60 seconds every minute I will be measuring that value. It gives 1/3 of the voltage. So if the voltage is too low, the battery is flat, and I display the low battery message to change it. I tested this by first modifying the code to check the battery level every second instead of every minute. Then with my power supply, I started with 4.5 volt and then went down, and I'm expecting the low battery to be around 3.5 volt. So low bat 3.3, so I went a bit fast, so I will try again. So I started with 3.74 volts, going down slowly, 3.49, and there it is, the low battery, so at 3.5. Perfect, it's working as expected. I bought a box large enough to fit the small breadboard, and here is my extra hardware. So the breadboard fits nicely. I have the battery pack for the 3 AAA batteries. I have an on-off button, and I have the reset push button. I also have somewhere in this box a diode to protect the battery power against the USB power in case I connect it by accident. It would prevent the 5 volts from USB to conflict with the 4.5 volt of the battery pack. This is what the top of the box will look like. I have the 2 holes for the buttons. Now for the display, they're not designed to be mounted on a panel or a box, so I don't really have a good solution. I will make a large opening on the box to fit the entire screen, but the sticky paper with the design will only have a small window letting through the area where the text is displayed. I'm not sure it will look good, but that's all I can think of. I printed a paper copy exactly to scale, and I'm going to score the plastic in the locations where I need to drill and cut for the opening. So I'm scoring the center of the 2 holes and the outline of the opening. I am going to discard this paper copy of the front design, but when I print the actual thing on sticky paper, I want it to be aligned exactly where the paper copy was. So that's why I put these two pieces of tape. It's just a reference to be able to align it. And now I use the score marks to put some tapes all around, so I know exactly what I need to cut. So the black part in the middle is what I need to remove. I need also to make a hole on the front of the box for the photodiode. I measured, and ideally it should be 1 inch from the bottom of the box, and I will set the score mark in the center 1 inch from the bottom. Now I am off to my garage to drill and cut the opening. I used a handheld rotary tool to cut the rectangle opening, so it's not very clean, but it will be hidden, so it's okay. Here is the final top design, printed on sticky paper and laminated, so ready to stick. I have soldered some wires for the diode and the display, as well as the buttons, so everything is ready to be assembled. And here is the front cover with the 2 buttons and the screen. The screen is held in place by tape, so it's not going anywhere. And that's it. So that's the front cover. We are almost there. I stuck the breadboard to the bottom of the box, connected the wires for the diode. Now I need to plug in all these wires in the breadboard and I will be done. And here it is, the final product. I have this flashlight with a blinking mode, so it's convenient to use that to test. And 54, and I get usually consistent readings. Here we go, 54. Alright, it's working. Done. Now I can put this device to good use. Thank you for watching, and until next time, this is Mike signing off.